with starting. Okay, first thing we're going to do is identify the vertex and the intercepts of a parabola. So, first let's do a basic one. Let's do x minus 4 squared plus 3 equals y, I guess, or f of x. So in this question, it will ask you to find the vertex and to find the intercepts. So that's the x-intercept, and that's the y-intercept. And then it could be multiple intercepts, technically. So for this one, we want to find the vertex. Luckily for us, the vertex is always h comma k. So h comma k, which means it would be, in this case, 4, because you flip the sign, comma 3, that stays normal. So this one's the vertex.
So which one's K and which one's X?
H.
K is the 3 and the H is the 4?
H is this one. K is this one. Remember to flip H value, okay? Second part is the x-intercept. When you look for the x-intercept, that means y equals 0. So I'm going to plug in 0 here. 0 equals x minus 4 squared plus 3. So I subtract 3 on both sides. Then I would square root both sides. But what happens when I square root?
Plus or minus?
Not that's true, but what else is the problem?
Because it's x minus 4.
That's not a problem.
Negative.
It is negative 3. So in terms of x-intercepts, it has no x-intercept. So this one will be none in this case.
It's a thing we can give you none of the best.
You could get none. If you square rooting a negative, it's no real intercepts, I should say. And then if you want the... What's up?
Does the x-intercept have to be 0?
Y equaling 0 finds you the x-intercept. Yeah. And then the y-intercept is going to be the opposite, where x equals 0. So in this case, I'm going to plug in 0 for x. So y equals 0 minus 4 squared plus 3. Minus 3 on both sides. Oh, wait, no. 0 minus 4 is negative 4. Negative 4 is 16. 16 plus 3, 19. Y equals 19. So y equals 19. So your y-intercept is 0, comma 19. Okay. I think I also ask you to graph. So because I ask you to graph, what you're going to do is first graph your vertex. So in this case, 4, comma 3. And then you got to make a table. You could use your calculator to fill out the table if you want, but 4, comma 3 will be the middle of your table.
We can do all this on test.
Yeah, there's one question.
How many questions do you think is going to be on test? Because all these problems are very long answer questions.
There's quite a bit. This is a fat test, honestly.
Really?
Yes. So 3, 2, 5, 6. So remember, because you put this the vertex in the middle, 3 and 5 are going to have the same y values, and 6 or 2 are going to have the same y values.
Why'd you start from 2?
Hmm? Say again?
Why'd you start the x value from 2?
I go 2 smaller, so 3, 2 from 4, and then 2 bigger, 5, 6. Then you would plug this in to solve it. Yes, if you want to make the table work correctly. So I just made this question up so the table won't like really fail on this, but so you plug in 3 into this. 3 minus 4 is negative 1. Negative 1 squared is positive 1. 1 plus 3 is 4. If that's 4, this is also 4. You plug in 2 in this one. 2 minus 4 is negative 2. Negative 2 squared is 4. 4 plus 3 is 7. This is 7. This is 7.
You could get this chart on...
You could also get it on your calculator.
How would you do that, though?
You plug in the equation you have, and then this second table. Either way, should be a parabola. If I see a straight line or some W shape, you got it wrong. Make sure it looks like a parabola, actually. Yes.
Can I just like make the shape?
I want points on the graph, so no.
So you start with 2, 7, and you go to 3, 4.
So I start at 4. So the first thing I do is 4, 3. I put that in the middle. Then from 4, I go 2 less, so 3 and 2, 5 and 6. And then from there, I take the 3 and plug it into the original equation.
So to find the y values of the 2 left and 2 above,
I just plug in 3 into the equation. Or if you go to your calculator, you put in the y equals. So you click y equals, plug in your calculation, and plus second graph. The button is graph because that will give you the table. And then the table, you can just scroll up to where 4 is and look 3, 2, 4. Plug in 3. 3 minus, if you just did this, 3 minus 4 squared plus 3, you will get 4. You could just do the work.
You plug in 3 to what, x?
No. You would put in x minus 4 squared, all squared, plus 3 into your calculator. Like this, if you want to graph it in the calculator.
No, I'm saying, how do you find the
Second graph will give you the table values.
without doing the calculator?
You plug in 3. So 3 minus 4 squared, which is negative 1 squared, which is 1. Then plus 3. 1 plus 3 is 4. You just literally plug it into your equation. Yeah.
You plug in a 7.
No, I'm not plugging in 7. I'm plugging in 2.
Are you able to like check it? Because it doesn't work.
For what?
If you plug in a 7, see if you get
7 for y?
Oh, yeah.
Okay.
Why'd you put 0 in 19?
That's the y-intercept. So that's where it hits the y-axis eventually.
I'm gonna. I literally. How do you get 19 from y-intercept?
I plug in 0 for x, and then I solve.
Oh, y equals 19.
Yeah.
Okay, I get that.
What then?
You just overthinking the x.
So if you have none, it's just 0.
You're overthinking it. It's literally just to do 2. I would do 2 minus 4 squared plus 3. Negative 2 squared plus 3.
Okay.
Yeah. You literally just plug it in x. So like nothing tricky on that. All right. Another graph in the quadratic, but it looks like this. So you're graphing this quadratic. What's the problem in this case? It's not in what form?
It's not whatever that form is. Vertex.
Yeah, vertex form. Yeah. We've been. So then, from here, we're going to get into vertex form. In order to get into vertex form, first what I'm going to do is take out a 3 out of these first two numbers. So 3, x squared minus 4x. And I'm going to do, remember, it's going to be a complete the square. Do you remember completing the square? Does that sound?
Yeah.
So I'm going to add a, what number?
A 9?
I don't know yet, so I'm going to put a C. What the hell? C.
Why is this getting mad?
It's 4.
Yes.
Yeah, it's 4.
Now, what's on the outside of here? It'll be plus 11
Plus C.
plus, or minus C, but it's technically not just C, it's 3 times C. So minus 3C, okay?
What?
Wait, why is it 3C?
Because the C on the outside is getting tripled, so you got to triple it here. So now, you would find C. To find C, you always do B over...
Oh, it's
B over
2 squared. Right?
Yes, B over 2 squared.
Right. Okay.
So now the B value is negative 4. Guys in the back, stop talking. So negative 2 squared. Pay attention to that negative 2. So that's going to be a positive 4, which means a positive 4 here, which means I'm going to plug in a positive 4 over here also. So in this case, I'm going to rewrite this. 3, and I can reduce this. I have no clue what you're saying. Just sit down. So I'm going to rewrite this as x minus 2 squared. Either you could think about it because you're factoring a 4, like 1 multiplies a 4, that adds a negative 4. Or you know that since the value before you squared it was negative 2, it will pop up negative 2 over here. Negative 3 plus 4 is a 12. So 11 minus 12 is minus 1. So y equals that. Yeah, what's up?
Is it always a positive C inside the parentheses and then negative C on the outside?
Yes.
How'd you get negative 2 minus 2 squared?
Minus 2 squared? Negative 4 divided by 2 is negative 2.
Yeah, but it's 4. All the C is 4.
It's the B value, which the B value in this case is negative 4. Okay.
So would it be,
What?
so how did you get 3x minus 2 squared? It should be
Oh,
4.
so if it's 4 here, you ask yourself what multiplies to 4 and adds to -4. That's -2, -2. -2, -2, that's the same thing. So I can rewrite it as x minus 2 squared. And it's on purpose it's the same thing because you
Y
wanted
minus
it.
4, or minus 1 on the outside.
Where's the -1? Because it's -3 times 4, which is -12. 11 minus 12, -1.
Well, that's just the beginning of the problem. This
Yeah,
is
we could start.
Yeah.
Yeah.
Like this is the step we got. Like this is the first step in the last time.
This is like step 0. Now we can start. Yeah. So now we get the vertex. Remember it's HK. Flip your H value. So it's 2, comma 1. -1. Thank you. So 2, comma -1. The x-intercept, remember you plug in y equals 0. So 0 equals 3 x minus 2 squared minus 1 divided by 3. Oh, wait, I'm sorry. Plus 1 divided by 3. So that's 1/3.
Frick, open the sugar.
X minus 2 squared. Square root both sides. Now in this case, do I actually expect you to do the square root 1/3? No, just leave it as a square root. Plus or minus equals x minus 2. And then I'll plus 2 on both sides.
Wait, so why is that one allowed? Is that allowed?
There's no negative here. I can square root a positive number. Equals x. So these are your x-intercepts here.
If you win, you're in the semifinals. That's how it works.
I said I answered you.
Okay.
Need that badly.
Now y-intercept is when x equals 0. So I'm going to take a 0 and plug it into this equation. So 3 times 0 minus 2
What is going on?
squared minus
What is
1.
that 2 in the middle of the board?
So 3 times 4 minus 1, 11. By the way, you could actually figure out the 11 from the standard form. Because remember, the c value is also your y-intercept.
Wait, so why is it? Why do you have to add the 2? If it's one, the square root of 1/3 equals x minus 2.
X is not by itself yet, so you got to put the 2 on the other side.
Oh, so it'll be 2 plus the square root.
2, I should say 2 plus or minus the square root of 1/3. If it was a clean number, you would actually do the clean number and find 2 numbers. So you don't have supposed to graph the x-intercept, so you don't need to worry. You only graph the 5 points we talked about.
That was like really.
So make your vertex
But then I
2,
didn't work out.
It's correct next to the 2.
make a table. 2, -1, 1, 0, 3, 4. You would plug in a 1, do the math. That should be 2. Then you plug in a 0. We actually know what the answer to that is, 11. So then you get the double, 2 and 11.
You had so much fun today.
And then just graph that, okay? I'm moving on to the next thing.
Stop interrupting.
Next one.
I know. I just
Find the equation. If the vertex is 2, comma 3, and you have a specific point at -1, comma 6. So, we're going to find the equation. In order to find the equation, we're going to plug it into the vertex form. The generic vertex form is y equals a, x minus h, squared plus k. Because we have a specific point, this will work as our xy, and the vertexes are h and k. Which means when I plug in the numbers, it's 6 equals, I don't know what a value is yet, -1 minus 2 squared
why didn't we graph?
plus 3.
Why didn't we graph?
I just want to keep moving. But I made the table.
Need be
Yes.
How do you do the table without graphing?
What do you mean? I make the table to graph. What do you?
Oh, you just plug stuff in.
Yeah, I just plug stuff in.
I'm gonna kill every. In order to make that plug stuff in nonsense, I think the adding the going.
Is that right?
So A,
Oh, we're good.
negative 3 squared plus 3. 6 equals 9A plus 3. 3 equals 9A. A equals 1/3.
Is that G or 6?
They're all A's.
No, on the outside.
What?
On the outside. Oh, it's a 6. I thought it was a G. I was about to ask you, why is there a G?
What are you talking?
See the G? I thought it was.
Oh, it's a capital G.
I thought it was a
yeah.
G, but it's a 6.
So then you're going to write the answer. Y equals 1/3
Banging and slanging.
x. You plug in a 2, so minus 2 squared plus 3.
You actually think so?
And then you do the whole.
Take it before working out.
All I'm asking you is for the equations, or you're good with that?
They're good if you're like trying to like do heavy weights, like deadlifts and stuff.
Okay. Next one is a blast from the past.
You're always laughing. Like you're always on the road.
3x minus 4 squared plus 2.
But it's a blast from the past.
Yep. So this is going to be talking about transformations.
So is it you got
I want to talk about split. That's messed up.
Chris, talk about split to see what.
So 3 parentheses x minus 4 squared plus 2. So I asked for transformations. So since the a value is 3, there's a vertical stretch by 3. H, that is a positive 4. So that's right 4. And K is a positive 2, so that's up 2. That's all you need to do for that part.
Was this in the last test?
It was on the last one.
That's why he said it's a blast from the past.
It's gonna be on the test though?
What?
Which one's H, K, and the other thing? Which one's which? H is the one in the inside,
Yes.
K is the outside.
Yes.
What's the 3?
A.
A is like up or down, like stretch or shrink.
Yes. And it also flips it upside down if it's negative. All right. Oh, let me follow up on this question. If I ask you for the minimum or the maximum, it's just the y value of the vertex. Because it's either going to look like this, where this is the minimum, or it looks like this, where this is the maximum. So it's always just the y value if I ask for minimum and maximum. If I ask for the minimum or maximum of a parabola or quadratic, it's always just the y value of the vertex. Oh, this is not the right thing.
Oh, so you see it when you grab it.
Yeah, you see it when you get the vertex, which is in this case -1. That's this in this case is the lowest it goes to because it's open this way.
Oh, so for just the y.
Yeah, just the y. That would be the minimum value it reaches. That's the lowest it goes. This one, determine if it's the. So we call this the end behavior. If you remember this part. So let's say negative 6x to the third plus 7x minus 8x to the 6 plus, I don't know, 2x4.
This is all random.
It's random. So this is end behavior. End behavior, if you remember, is that based off the highest power decides, does it look like kind of like a parabola where you go positive, it goes positive? Is it like this?
No.
If it's like this,
No.
or is it like this? So this would be an even positive, so like positive 2. This would be a negative, so negative 2. This would be an odd positive. So, and this would be a negative odd.
I knew it. It'll be upside down problem.
So in this case, the end behavior
2 and 2 and 3 and 3
is decided by what? This is the power. So if it's an even power, like 2, it will look kind of like this. So in this case, you only look at the highest power. So I don't care about this. Don't care about this. Don't care about this. I only care about this. I look at 2 things. 1, what power is it? It's even. So this is crossed out. Then I look at the power or the coefficient. It's negative. So that's crossed out. So I know the end behavior looks like that. So this is how you write your answer for the end behavior. As x goes to positive infinity, aka it's going to the right, that means it looks like it's going down. So that's negative infinity. And as x goes to the infinity, negative infinity, aka go to the left, it's also going down. So it goes like that. So that's how you write your answer right here.
What if it was for the cotangent one?
This one?
Yeah.
This one would be as x goes to infinity, so right, y is going up, so positive infinity, and x goes to negative infinity, as to the left, that'd be negative infinity. Okay? All right.
Yeah, I did.
All right. Next one, graph the function. In this one, you're not getting the specific points. Let's do the...
I didn't know you guys were friends. Honestly, I don't even really decent think I did.
9.
I was friends with him all last year. This year, I just like.
Actually, let's do it like this.
I'd be with you. That's
All right, this one, we're going to graph this. Now, graphing this seems pretty tough.
Oh, really? It's easy, no?
It is really easy.
For someone who loves math,
last
like
one,
you.
why wasn't infinity?
What's up?
Why wasn't infinity?
I'm asking for end behavior. So that question, you give me that kind of answer. If I ask you to graph, then we're going to do this.
But wait, so why is it infinity then?
What's up?
Why is it infinity?
What do you mean? Why is infinities here?
Yeah.
So I'm talking about the end behaviors. AKA, what happens as I keep going to the right, as I keep going to the left? So in that case, if I keep going to the right, I'm going down. So that's saying here, if I keep going right, that means I'm going down. So that's what's represented by the infinities. And the negative infinity of x means I'm going left. I happen to be also going down.
Right? On the x's are always positive and negative, right?
This will be the same order every time, yes. If you do it consistently, it's the same order.
No, and so if you go negative infinity, then it goes left. It goes down.
Yeah. Negative infinity means go down. And if this was positive infinity, it goes up. So if you see this one going right, I'm going up. Right, I'm going up. And then left, I'm going down. So left, I'm going
So
down.
why does it go down if you go left?
In this one, it does, the cube one.
I thought we were looking at the upside down problem.
No, I am, but Samuel asked for this one, so I just want to point
I'm
out.
saying if you go left in the upside down problem, why is it going down?
Because it's a negative even power. So it's got to look kind of like this. And because it kind of looks like that, the arrow kind of looks like that. You're going to see where it shows up or how we use it in the next one. All right. For this one, we want to find all the zeros and the end behavior and then work from there. So first I'm going to find the zeros. I'm going to factor out t squared out of both these. So I'm left with t squared minus 9. Then t squared minus 9, can I factor that?
Yeah.
What does it become?
T plus 3 and T minus.
Yes. Abby, you could talk. Okay, fine. All right. So in this case, my zeros are at 0, negative 3, and positive 3.
That's a 4.99.
Oh, idiot, paid $30. So stupid.
Can you stop talking? So in this one, so we're going to do the number line, but if we know our double roots, we can actually do this quickly. What's up?
What if I don't want to do that?
Then you just plug in for each section. So I'm going to show you. If you plug into this section, so plug in, I don't know, like a negative 4, something that's smaller than negative 3. In this case, over here, you know it's going to be, if I plug in a negative 4 into this, that'll be a positive, because negative 4 squared. That's a negative, and that's a negative. Overall positive, which means it should be above the y-axis. Because negative 3 here is a single root, I know it's going to flip, so it's going to be down. If you don't trust me, you can plug in negative 1 and check. 0 is a double root, which means it's going to maintain. So it's still going to be below. And then 3 is going to be up. We also could tell from the end behaviors. T to the 4th matches a positive parabola, which means I know my arrows should be here. and here. From the zeros, I know it's at -3, 0, and +3. And then when we graph the line, we just connect the dots. Here, it starts up and I'm going down, so I'm going to be below. From here, I was down and I'm down again. And here, I'm down and I'm going up. So it matches that. That is a quick way to graph that function. We're not going to be particular about like how bumpy this is or something like that. Like if you drew it like this, that's also okay.
So if you why are there up and down arrows in the on the number line thing?
Oh, it's I always say positive and negative, right?
Yeah.
So if this is positive, that means my y values are positive. So I'm just putting arrows to like indicate more to me. This is negative, your y's would be negative. This would be negative. This would be
So you
positive.
do like a 4 things for number line?
You have 4 gaps in this case, yes.
Wait, do you need the number line? Because
After you get the first one, no. Or you could actually do it from the end behavior and
yeah.
figure it out from there. You could. I would say at least do the number line to do the first one.
-3 and +3 and t squared to bounce off there. So
You absolutely correct. You could even do it with just the end behaviors. You never technically have to plug it in. I'm just showing what I find most people understand, which is at least plug in one, then do double roots.
Can you say how you do how you know if it's double root?
Sure, because in this situation, it's t squared. So you could think of it as t times everything here. So that means this is 0 and 0. So because it's a double root, or squared, it happens twice. Because it happens twice, it's like a single root would be just going outside the door. A double root would be going outside the door and back inside the door, which means I went through the doorway twice, I'm back into my same position. That's why in a double root, you start at the bottom, you're still in the bottom, in this case.
Oh, and then if it's like, how do you know that the 3 was a single?
The 3 was a single?
Yeah,
Because there's only 2 to 1 power.
So what is the number line?
This helps you figure out which ones should be above or below.
If it was like the t cubed one, how would that look?
A t cubed? Your zeros would be different to match that.
Oh, so but there will only be like one.
The max amount of zeros you could have for a t cubed is 3. The max amount you can have 4. In this case, we have a double root of 0. That's why we only have 3.
Wait, how can you have 3? Because... Oh yeah.
Yeah. So the max you can have is 3. The max you can have is the n, and the max amount of technically bumps you could have is n minus 1. So you could technically have 3 bumps because it could have looked like this or something, where it's like 1, 2, 3 bumps in that case.
Yeah.
Okay. All right. Next thing. Let's see. We just did graphing.
I'm still lost on what the number line does.
Don't.
Because if you what are you looking for in the number line? If it's positive, just like use it. Usually there's a purpose to the number line. There's no purpose here.
The purpose of the number line is this is a positive section, which means I know this part of the line should be in the positive y values. This is the negative section, so I know this is a negative. It's a way to check you're graphing it correctly. As Samuel pointed out, because you know it starts positive,
And it's double root.
and this is a single root you would go through, double root you bounce, you could actually figure it out by just using the end behaviors.
Doesn't that have 4 bumps or not like?
This one could have, no, this has 3 bumps. 1, 2, 3. Because this would go on forever then. When you do other problems with different answers, you'll see that at max it could be n minus 1. All right, perform division. So you're going to perform, in this case, we'll call it long division. Actually, let me write the problem how it looks like.
No one wants to say it. I can't say it. No one can say it. No.
24x squared minus x minus 8 divided by 3x minus 2. So we do this long division. So to do this long division, what we're going to do is we're going to write this as 3x minus 2 divided by 24x squared minus x minus 8. So the first thing I need to do is all the x squares should column, all the x's should column, and all the constants should column. So what I'm asking myself is, how can I make this part here, 3x, match 24x squared? What could I multiply with 3x to match to 24x squared? 8x. Since that's 8x, or x to the 1 power, that's going to be on this column. So we're going to write 8x here, okay? Which means I'm going to take 8x and multiply it with 3x minus 2. 24x squared. 8 times negative 2. Negative 16x.
We're doing long division?
Yes.
I hate long division.
So we're subtracting all the way down.
Egg is a long division.
We did a long division.
And I'm saying like first grade, moving down from the egg is a long division.
Yeah. Don't move
Uh.
down. Yeah, stupid.
I was never done. Right now.
Hey man.
So 15x. I'm recording.
No.
Now our next thing is,
It's 17.
it's minus. So negative 1 minus 16 is negative 1 plus 16. So it's 15. Then we're going to bring down the negative 8. Now I'm going to ask myself, what do I get 3x? What do I multiply 3x to match with 15x?
I'll give you
5.
the covered almonds if I get next time.
I'm recording.
Shut up.
So it is 15x.
Minus
5 times negative 2. Negative,
two remainder.
negative 10.
Two remain.
So subtract down. So that's 0. And I'll be positive 2. So you're going to write your final answer like this. It's 8x plus 5 plus the remainder 2 over my original divisor. 3x minus 2.
I think that's enough for you.
That's weird. My old best friend.
Seems like the people are knocking, so we'll call that one for today. We'll continue tomorrow.
Yeah, this is the one for